this lesson will complete the discussion of data abstraction and object-oriented programming of the last two lessons with presentations of three topics: Java, multiple inheritance, and exceptions. So Java is a very popular object-oriented language that has had an extreme success since it was first created in the early 90s, and it has a lot of support for practical programmers. So showing this language will give us really an example of how the theoretical ideas of data abstraction, object-oriented programming, how they work out when confronted with reality. The second topic is multiple inheritance. This is when a class inherits from more than one other class. In fact, this is a very powerful concept, but very hard to use. We'll explain the problems with this, and we'll also explain how Java solves this. And the final third concept is exceptions. So exceptions are a concept in an imperative language that's used to handle error conditions, things that tend to be rare, program errors, but also errors from outside the program. And we want to handle them without making the code of the program more complicated. So let's talk first a little bit about Java. So Java is in fact the most used programming language in the world today. It has an enormous support, libraries, tools, high quality implementation, the JVM, Java Virtual Machine, very large developer community, and a company which is devoted to improving it called Oracle. But Java is already a fairly old language. It's more than 20 years old. It has many competitors, and I've chosen three of them, C++, Scala, and Erlang, which exemplify other parts of the space and maybe do certain things different or better than Java. So C++ is a language that's closer to the processor. It gives you real access to the low-level parts of the implementation. It's in fact older than Java, but still extremely popular. Scala is a more modern language. It's a functional object language with the principles of consistency, where it distinguishes between mutable and immutable, and where everything is an object, even the functions, so it has functional objects. And it's built on the JVM, so it's in fact very interoperable with Java. It's a very strong competitor to Java today. The third language is Erlang. Erlang is a language of very different execution model. It's extremely concurrent. It's built on message passing between concurrent agents, and it's used for building highly available applications. That means applications that keep providing a service despite failures around them in the software and the hardware. So Java is a foundation here. So in this lesson, we're going to try to understand the execution of Java. So I'm going to talk about the Java semantics. I'm not going to give the complete semantics. I'll talk a little about the paradigm and the support for certain things that Java has, and we'll give certain examples of Java semantics that will show with the abstract machine so you can understand what Java is doing. I'll talk a little then about Java support for object-oriented programming and some limitations of Java. So to start, let's contrast two languages which are in some sense similar, but in some sense different because they have different design philosophies. So Java and C++. Both of them implement imperative paradigms with concurrency. We're not going to discuss concurrency in this lesson. We'll discuss it in the next lesson. But both Java and C++ implement what's called structured programming, where a programming is a set of nested blocks, where each block has a single entry point and a single exit. There is no goto. You cannot arbitrarily do control flow in the program in Java. In C++, there is actually a goto because of the low-level focus of C++. This is sometimes important. The second point is that both languages have imperative control structures inside the blocks. If statement, switch, while. We saw the while loop several lessons ago. For loop, which is a while loop with a bounded number of iterations. Break, return, so ways of exiting, entering blocks. So the basic difference in the design philosophy of C++ and Java is that C++ gives access to the internal representation of data structures. You can even look at the stack. You can look at how data structures are presented in terms of their bits. And the memory management in C++ is manual. It is the programmer's responsibility to free objects when they're no longer being used. Java has, in this sense, a completely different point of view. Java hides the internal representation. It is not possible to look at the internal representation of data structures. Memory management in Java is automatic. Garbage collection. In fact, Java is one of the languages which first put garbage collection into the mainstream, where it was considered slow and unusable before that, but Java showed that this was not true. So this was one of an innovation of Java. So here's a simple example program in Java. So it's a class, Fibonacci, with a method called main. So all programs have a method main, and this method is executed when the program starts. So this method has 3 modifiers, and here we have inside the method 2 Java variables. In Java they're called variables, but in our terminology these are called cells, low and high, with declared types, integer. We have system operation to print things, and then here we have a while loop. We have here assignment statements and a conditional. So these local variables must be initialized before used. Notice that these integers are abstract data types and not objects. So Java does not just have objects. The method println here is overloaded. This means there are many methods with that name, and the implementation will choose the right method depending on the type. This is called static polymorphism. It's a different version of the polymorphism we saw before. So all methods defined in classes in Java can be given modifiers. So let's give a brief overview of the 3 modifiers of the main method. So the public modifier modifies visibility. Who has the right to use and see this method? So this means, public means it's visible in the whole program, no restrictions. Static tells you how the attribute or the method was created. Does there exist one per class or one per object? When I create several object instances of a class, do I create new versions of the method or of the attribute or not? Static means it's created together with the class and not with the object. And void is the type of the return argument. Void means there is no return argument. Void is not a type of a value. This means the method returns no result, so it's a procedure. The method has one argument, which is a string array. So an array that contains string objects, where a string is a sequence of characters.